Good afternoon, everyone. I'm Mohammad Ali Rangwala, Application Engineer at Engineering Technique. I welcome you all today to today's webinar, Industry Specific Demo, which is focused on solar industry. आज हम सिर्फ सॉलिडवर्क्स के फीचर्स ही नहीं बल्कि उसके साथ साथ पूरा एक इंजीनियरिंग वर्कफ्लो देखेंगे from starting of design, documentation, validation, and at last, how will you able to manage all of your engineering data in 3D experience. So before we start this today's session, I will quickly explain your today's agenda. So in our today's agenda, we are going to cover following points. I quickly go through you to the solar industry and what is the current scenario in it. Then what are the key engineering challenges that are being currently faced in it. Then we'll see what the workflow, digital engineering workflow that we are going to follow in our today's demonstration. Then, from SolidWorks point of view, we are going to see parametric modeling, assembly, simulation, drawing, and visualization. And at last, we'll see how all of the data which is being generated by SolidWorks will be managed with the help of 3D experience. Now we know that currently in the world, it is moving to global transition to clean and sustainable energy. Government and industries are investing heavily in renewable energy and related sector, in which solar energy is one of the fastest growing sectors. But if we talk about the scale of the projects in solar, we are not only talking about a single model. यहाँ पे हम पूरे प्लांट और मल्टीपल थाउजेंड्स ऑफ मॉड्यूल्स एंड स्ट्रक्चर्स की बात कर रहे हैं, जिसके साथ साथ हमें मल्टीपल चैलेंजेस फेस होते हैं, जैसे हम कैसे सारा डिजाइन डेटा मेंटेन रखें, कैसा स्ट्रक्चर कैपेबिलिटी को मेंटेन करें और एनवायरमेंटल कंडीशंस को कैसे वो एब्जॉर्ब कर सकते हैं. So to bring out the challenges that are being currently faced in this industry, I will show you the following challenges that are being faced right now by our engineers and in the solar industry. So first is, we know that the solar project is a very if the solar is a very large scale project, then it contains thousands of modules and structures. While we need to maintain the components accuracy, design, and structural capability throughout the plant. To manage that, it is somewhat difficult for our engineers. Then, to minimize the uses of material and maintain the cost of the whole project, it is also need to be reliable and it needs to be under the budget scenario. Now, handling continuous design requirements and without the delaying of the project, it is very essential to communicate with the customer. Then, after you have created a design, you need to be able to communicate with the fabrication and manufacturing team so they can generate easily produce or manufacture your desired structure and model. So to counter all of these challenges, we'll see how we can counter all of the problems through our digital engineering workflow, which is recommended in this. So in our today's session, we are going to follow this particular workflow. We already have a concept of solar in our mind. We'll begin with parametric part modeling, assemble all of the parts which are created. Then we'll see how it is visualized and validated through SolidWorks and simulation. Then finally, we'll see how we can generate fabrication ready drawings through our drawing. So to begin with this, I'll first tell you about one question that generally comes in mind. The first question that comes in mind is why SolidWorks? Because to understand this, we need to understand our objective here. Our objective here is not to just create a simple model or a particular one part. We need to create multiple modules and structures. And also we need to ensure that they are able to handle design revisions and multiple design changes which occur during the whole project timeline. And the main is will it able to sustain the environmental conditions structure capability. So how will we able to determine that? So SolidWorks offers you those solutions in one software only. So let's see each of the challenges one by one. The first challenge, which is frequent design changes. So let's imagine a scenario. In multiple solar projects, if you are working on an existing project and some minor changes are coming and customer is demanding that in a single part or an assembly, some changes are required, but you already have that assembly ready from your previous project. So आप उसे वापस रिक्रिएट करने जाओगे तो you need to invest more time in that rather than just applying the required changes customer suggested. So उससे आपकी डेडलाइन मीट करना हार्ड हो जाएगा and you will not be able to coordinate with customer. So हम सॉलिडवर्क्स हमें इसके लिए सॉल्यूशन प्रोवाइड करता है पैरामेट्रिक पार्ट मॉडलिंग. इससे हम देखेंगे इसके बाद वीडियो में कि आप ये कैसे आपको हेल्पफुल रहेगा. So in this SolidWorks, I am in SolidWorks window and this is my assembly. Now if I want to make a simple change in my assembly, minor change in this part, I will simply open it. Now if I want to add a structural member between these support, I'll simply sketch it out first to make the reference. Now, if you want to align the particular sketch, you will be able to apply the relations. Then, after you have completed your sketch, adding the structural member in SolidWorks is also very easy because in Weldment's part of SolidWorks, it provides you with multiple categories through which you will be able to insert the structural members with a single click. Now, if you want to trim the boundary as it is interfering with the upper structure, you will also able to do that with the help of trim command. Now, if you want to pattern this particular object in all of the components rather than creating it again and again, you can also do that with the help of SolidWorks. Simply select the part and as you can see, it is created. Now, I will simply save this part and reopen my assembly. So, as you can see on the screen, my assembly is automatically updated. So, the benefit of the parametric in this is all your part, drawing, and assembly are interconnected through parametrically. And if you update part or make any changes in it, it will be automatically reflected in SolidWorks assembly and drawing. So your data automatically gets updated and you do not need to manually recreate every part or every drawing. So the advantages which we gain from this is it automatically updates all the relations and dimension in assembly as we saw. It makes the handling of design revision very easy. It also improves accuracy and consistency overall of your product. Then accelerates overall engineering workflow. Means if you are on a tight deadline, then it is very helpful in that condition. Then we also saw how the structural members are created with one single click. And there is also multiple library available. So you can select any one of them and apply it to your model. So now we have created our part, right? So main after that comes another challenge, which is managing complex structures. Means if you are making multiple parts, at the end you need to assemble it, right? To generate your final product and imagine it with the real life scenario. So the problems which come with it is aligning the particular parts, maintaining the interference between each other, and finally you need to imagine it in the real life scenario. Which while if that is not able to execute in the site installation, then that will be a wastage of your material. So in SolidWorks, the solution which it provides is assembly modeling. So हम अभी देखेंगे assembly modeling में कैसे कर सकते हैं. Now, as I inserted multiple components of my assembly, यहाँ पे मैं constant दे सकता हूँ to each and every part of mine with the help of SolidWorks Mates. यहाँ पे हम डायरेक्ट SolidWorks पर जब भी कोई फेस सिलेक्ट करेंगे तो वो ऑटोमेटिकली आपको प्रॉम्प्ट करेगा which mate is applicable here. As you can see, I have selected multiple faces and it has recommended me this particular mate. SolidWorks automatically recognizes what are the features that you are trying to apply while constructing it. So if it is not applicable, it will not recommend you. Now, as we saw the component pattern in part, it is also available in assembly. So you can simply pattern the similar parts rather than re-inserting and mating them. Similarly, for the module, I will make the component pattern here. You can also use the component pattern bidirectionally if you want, as you can see. Now my assembly is created, but at the end, if you want to view what are the parts that are in my assembly, you can create an exploded view animation like this and see each and every part of yours and where it is located. So the advantages which we get from this is it enables a complete visualization of a real life solar structure. And you saw right how we can easily make the components. So alignment and fitment is also applicable in SolidWorks assembly. Then you can also check the interferences and collision. If there is any part or component which is colliding with each other, you can determine that at an early stage. Then the main is it improvises the collaboration and communication between each teams. Because if there is any site team located at the particular site and designing team shares the CAD model data, they can check and validate that the component is okay or needs any required changes. So with this, we have our main assembly model ready. So now the question that comes in mind is, will the model be able to sustain wind and structural performance at the site in real life? Because if the model cannot handle the overall load of the module or it cannot handle the wind flow, then your model will become useless and you need to recreate it again and again. So to solve that, SolidWorks offers you the role of SolidWorks simulation. Let's see how it will help you. I have created this study here, and you can apply the loading conditions as per your site in real life condition. You can check stresses, strains, and displacement of your structure. Then, if you want, you can also check the wind analysis of your model. Means this it provides you computational space. You can adjust it by size. Then you can provide it wind computational data of what is the my current wind flow or how it is flowing, what is the velocity. Through that, you can check the projectile of the wing, and also if you want to see the animation of it, you can also animate it like this. As you can see now, you can check the animation of the projectiles, how it is moving above my structure. I will simply take this view to make it more clearly. So you can check the stresses generated here with the help of that. Now, if you want to export your data to Excel, you can do that also from this. All of your data which is generated through simulation will be exported in the Excel sheet with the plots and everything. Now, if you want to view the data in SolidWorks itself only, you can do that also. All of the data is available, and you can also customize your generated data. If you want any customized chart, you can also give the input regarding that, and it will help you generate that. So the advantages that we get from this is we can validate the structure at an early stage before it is fabricated in real life. So it reduces the error and material wastage. You can obtain the optimum material which is applicable to your product. So it will able to sustain maximum load capacity and wind performance. Then on-site testing and design iterations is also reduced as you have already tested the model and it is working fine in those conditions. So in that way, you can really reduce your cost of the project iterations and increase your overall productivity. So with this, we have completed our part, assembled it, validated. Now comes the challenge of how will you able to provide the particular model data to the fabrication team as they need to produce the particular part. So we know, right, that the fabrication team requires all of the dimensions and bill of materials. To provide that, we need to create a particular drawing, fabrication ready drawing of the model because the fabrication team couldn't get all of the data from the model itself. They need a particular views, dimensions, ballooning, and bill of material. To generate that, SolidWorks offers you drawing and documentation in it through which you can generate those drawings very easily. Let's see how it is generated. I am in my SolidWorks model window. I will directly go through the drawing part. I will simply insert some of the views of of my model. You can also select any customized view if you want. You can change this display style if you want it to 3D. Now, if you want to insert dimensions of a model, it is inserted with a single click. You do not need to manually give all of the dimensions. Now, if you want to arrange them, there is an option called auto arrange here, through which automatically SolidWorks arranges all the dimensions here without dragging and each and every dimension and placing it on the positions. Bill of material is only single click away. With a single click, you can generate your bill of material and whatever parts or the properties you need in a table format. So with this drawing, you can generate a fabrication ready drawing and make the input of all of the data that is required by the fabrication team. You can communicate with them and ask what currently are they expecting of the data of the model, and if they require any particular changes or analysis of the model, and you can determine that at an early stage before fabrication. So here also you will able to reduce the material wastage and increase your productivity. So now we have our documentation also ready. We have so let's see, we have created our part, assembled it, validated it, then also created the fabrication ready drawing. Now comes the part of a presentation. And also we saw the advantages, like what are the particular advantages that we saw here are you can generate the fabrication ready drawing, improves the communication between the teams. Like if you want to communicate with the fabricator, you can directly communicate through mail or share the design data with him and he will be able to generate the particular structure. So now the challenge which we are going to face is design communication. If you share your data or are going to present it to someone who is not a CAD user, वो CAD user नहीं है, वो as if it is a customer or a stakeholder, then you need to provide them a particular presentation in which they are able to visualize the model in real life scenario. वो CAD मॉडल से आइडेंटिफाई नहीं कर पाएंगे कि हाँ मेरा मॉडल रियल लाइफ में ऐसा होगा, and it they will be not satisfied with only CAD. They need to be able to identify through it real world view. So for that, SolidWorks offers you rendering and visualize. Let's see. If I am in my SolidWorks visualize window, I will simply import my CAD model in it. Now, if you want to change the particular appearance or the image of a model, you can do that also by importing external images. As you see, I imported the realistic photo of the solar panel. Now, if you want to apply any material appearance, you can do that. But if you want to change environments like background or make it more realistic by applying outdoor views, you can do that also. You can reduce the sunlighting effect, shadows, increase the scale of your model. Then, after all of the particular changes applied, you can simply do the rendering process and check if your model is as per your needs and as per customer needs, and you can show it to them. So the advantages that we get here is it improves the visualization of the assembly of the CAD model, and you will able to tell the customer that how the model of theirs is going to look in real life, and it will improve your presentation points and marketing output to them, and customer will gain more confidence in your productivity skills and how will you able to achieve the particular goals which are provided to you by them. So now for a SolidWorks point of view, our main designing part is over, but the engineering workflow does not end here, because now we have our parts, assembly, drawings. Also, we have validation data of our that we conducted through simulation and visualization. So the question comes in mind is where will we save all of the data? Because if we want all of the data in a single platform, right, not in different folders. So in that case, this is where 3D experience comes in. It is a cloud-based platform that connects people, data, and process in a single environment. Means so if you are saving all of your data in 3D experience, it will be maintained in a single space. No particular different folders and no extra subfolders or anything. It will be in a common space to which you will have access, and you can also provide the permissions to other users or your design head or any stakeholder to the space, so they can check the model data and also check the project status. The main advantage is in here is you can check the model data from anywhere. It is not required that you are available at the system or the workstation or the office only. You can even check it from your phone simply by logging into your cloud platform and then checking the CAD data by simply viewing it on the platform. But the question is, why 3D experience? So the challenges which are being currently faced in the real world scenario and the projects are: data is stored in a different locations, right? Multiple offices of a company are available. So some of the data is in a different location and other in different location. So the difficulty tracking revisions means if a customer in a project asks you to make some changes in a model, and it also occurs frequently. So how will you able to generate all of the revision in a single file or a common space? Because you need to save it again and again and maintain a copy of it in other folders. The collaboration of the teams are communicate through mails, which is not very efficient. Limited visibility of the project status. You cannot view what is the current state of your project ongoing. Difficulty in sharing CAD data. We saw that how will you able to share the data to a non-CAD users, and feedbacks are scattered only in meetings, means you cannot share your feedbacks or project uh, changes on the real life in a world collaborative space. You need to share it in the meetings only, and limited access to design space outside the workstation, as we saw. So the solution which 3D Experience offers here is, it is a secure cloud storage. Means you will be able to get the secure all of your security and data management all in a single platform, in a single space. Then version and revision control. You will be able to control all your revisions throughout the model in a single space only. You can even roll back to your previous revision if you need any previous version of your file here. And it is real time collaboration, means you can communicate with other teams in real time and ask their feedback and update it in your project. Then you can view CAD files from any device. As I told you, you can even log into your phone or tab on the platform browser. Then simply log into 3D Experience platform and you can access your files from there. Then if you are visiting a customer site and customer says that he wants some changes to your product, his product, which is being manufactured by you and designing by you, so you can simply take out your tab or for device there and simply do the markup of it. What are the changes that customer requires, and simply share it with your designer from there only. So the work and the project communication is also improved through this. The challenge first which you face currently is version control and data security. The solution which is offered by 3D Experience is saving the data through 3D Experience. I will simply show you how your data is being saved right now. You just have to simply right click on your main assembly file, then select your collaborative space on which you want to save it in the 3D Experience platform. Then all of your parts and data will be start saving to the platform. After the file is being saved, its status will be changed. And as you can see, the log status, right? So this indicates that no one will be able to make any changes to this file unless you unlock the file. So the security in this is also maintained. You can also see the revisions which is currently displayed. If you make any changes in particular path, you can change the revision also here, and you can display that in a particular one folder only. So The advantages that we get from this is it is a centralized storage for all files. It is you can control the access for any team members. If you want only a specific number of people to access that particular space, you can apply that also. Then, if it reduces the time which is spent during managing local folders or subfolders in your local drive. Then, it also improves the collaboration between teams. Like if there is any site personnel located on the site and doing some inspection, you can directly communicate with him through 3D experience and let him know the data which he requires. So the next challenge which we are going to see is file sharing and data accessibility. We know that, right? That currently you are sharing the file to the customer or stakeholders with through mail or attaching it with some of the other external softwares. But what if 3D Experience offers you in its one of the roles, which is 3D Drive, in which you can directly share the particular link of your model and through the external person, they will directly receive the mail and able to open the file without the SolidWorks or CAD software. There is no requirement of any CAD software to view the file. So let's see how it works. In here, file option, I will simply click the share button and my file will start uploading to the CD drive. You can also select the format of your file. If you want any particular step file or STL IGS, you can select that also. After my file is uploaded, you will get this pop-up window, which is shared with external. You can enter the person's mail ID whom you want to share your file, enter a description if you want. Then simply click on share. Then you will get the pop-up message uploaded on 3D drive, and the external person will receive this kind of mail in his inbox. And after, if they want to view the file, they will simply need to click on this link which is provided with the mail, and they will able to view the file. So the advantages which we get from this is you can seamlessly share your file without any external format or anything. We saw how many formats are supported. There are multiple formats. Customer can easily view the file without any CAD software required. They can directly view on their browser. And it is secure and reliable. Means there is no any leak or external leak here. They will directly receive the mail without any interference from third party. So the next and last is one of the challenges which is design review delays. It is also known as a feedback delay because we know, right, that if one of the we visit one of the customer site to review the project status and show them the current product development, they suggest some changes required. So generally in common scenario, you will take the customer's feedback, go on the next day and inform your designer. So he will start making those changes. But in 3D experience, the 3D by using the 3D markup, you will be able to create the particular feedback on your any device, tab or phone, with the customer, and you can show him that these are the changes that are required. And if the customer approves, you can directly send that markup to your designer. So from that point only, the designer gets the particular feedback on the product and will start working, and the it will also help to improve and meet the particular project deadline. So let's see how that particular works. In 3D Express platform, I will open my particular space in which I will open this particular assembly with 3D markup. Then after my assembly is open, now I want to, if the customer suggests that it needs to be updated or some changes are required, I will simply create a markup, apply the particular annotations here, which customer recommends. And you can also add the comments here to let the designer know that these changes are need to be applied. So in this way, you can easily communicate with the designer and let him know that the customer is requesting following changes. So start working on that. So the advantages which we get from this is there is a clear design communication. Means you will be able to communicate with customer and designer both and know what are the changes that both are suggesting and will it be possible or not. The review cycles are obviously faster as we know that you will able to provide the feedback from customer directly from site to designer and it is accessible from any device. No CAD software is required to view the particular files. You can directly view them on 3D platform and the issue identification of the model is very simplified here. So with this, let's we have concluded all of the challenges that are being addressed and provided here solutions which are SolidWorks and 3D Experience offers. So let's get a quick summary and key takeaways what we saw today. First, we saw parametric design in which we saw how your model is being updated if there is any minor change and no need to create the whole assembly again. Fail bands and assembly. We saw how the easily structural members are being created with a single click. And in assembly, how you are able to apply the mates and align the components perfectly. And also check the interference and collision detection. Then we saw how you can validate your particular model. You need to verify its structure, the performance, wind analysis. You can do that also. Then we saw how you can easily generate fabrication ready drawings and easily communicate with the fabrication team. Then we saw how if you want to present it to a stakeholder or customer, you will be able to visualize your product and make it look realistic. So they will able to identify more easily and gain design confidence in their product. Then we saw through 3D experience how you can manage your data and improve your site team's collaboration and improve your project timeline. Then finally, we saw how 3D drive and 3D markup means how you can seamlessly share your file and create customer feedbacks from there only and provide dedicated feedback to your designer and through which he will be able to deliver the outcome more effectively and more timely. So the cycle of this whole demonstration follows like this. We need to design our product, validate it, we need to generate a documentation of it. Then we need to visualize our product for marketing and presentation purposes. Then all of the data needs to be collaborated so we can collaborate with each other, each team, and finally deliver. So with this, the our today's presentation comes to an end. I hope you have gained a considerable knowledge and more informative session. If you have any queries or require any more clarification, you can connect with us or you can ask now. If you want to connect with us to know how SolidWorks or 3D Experience can help your organization to get and benefit your organization, you can connect to us by connecting our marketing team and they will able to connect you with through our technical team and we will able to discuss the further steps and how SolidWorks and 3D Experience will help you. So thank you. If there is any question, you can ask now.